Scientists have the most precise reading yet on how fast Earth's magnetic poles could flip. An analysis of the stalagmite from the depths of a cave in China has unveiled clues about an event in Earth's history when its magnetic field flipped back and forth in a geological blink. Not only was this rapid wobble a surprise, a similarly abrupt shift in the near future would almost certainly pose big problems for societies heavily reliant on digital technology. You only need a compass to know we're surrounded by a force that lines up with the globe's axis, pointing steadfastly towards the Arctic, while its tail shows the way to the Antarctic. This unseen bubble of magnetism is generated by swirling currents of charged particles deep under our feet, but we still know surprisingly little about its formation or how the magnetic field of the Earth evolves. Fortunately for curious geologists, the magnetic field leaves an indelible mark on Earth's crust, frozen in place inside solidified igneous rock. Magnetized materials and minerals can provide clues on the field's orientation prior to their cooling. So imagine the surprise of French geophysicist Bernard Burns when, in 1906, he found volcanic rocks magnetized in the reverse direction. 20 years later, Japanese geophysicist Motonori Matuyama tested Burns' suspicions, providing the first concrete evidence that our magnetic field is rather wobbly and has not always pointed in the same directions. To commemorate their contribution, the last big reversal in the field's polarity was named after the two scientists. Matuyama-Burns boundary, now described the event 780,000 years ago when south became north and north became south. 780,000 years ago. It was the last time that's around the time, 760,000 years ago, was it around the time that we had the super eruption of Long Valley Caldera in California. Now, it says here it was the last time this monumental reversal occurred. Smaller deviations in the pole's positions, called geomagnetic excursions, seem to occur far more frequently, including a weak flip-flop about 41,000 years ago, when the field weakened to just 5% of its current strength for a few centuries. Can you imagine having no magnetic field on the Earth? We only had 5% 41,000 years ago. Pinning down our understanding of changes in the magnetic field is far from trivial, given that this bubble does a fine job shielding us from high-speed charged particles shot from the sun. So our geomagnetic field, of course, as we can see here, shields us from the solar flares and CMEs of the radiation from the sun and also cosmic radiation. Now, without it, a lot of our electronic technology on both the surface and in orbit could be forced to cope with a bombardment that would risk frying their circuits. And we know recently, about a month ago, we had 40 Starlink satellites plunging to Earth and burning up in our atmosphere because of it was not even a direct hit of a solar CME towards us. So even where there's strong magnetic field today, we still are susceptible to solar storms that can damage our electricity-based society, says geophysicist Andrew Roberts from the Australian National University. If the field takes a tumble, we want to know about it long before it happens. Unfortunately, we don't really know what clues to look for. Igneous rock does a good job of capturing a snapshot of the magnetic field's direction, but finer movements in the lead up are often missing. So together with an international team of researchers, Roberts sought out to a slower growing source, a stalagmite growing on the floor of a cave in Guizhou province, southwestern China, proved to contain the perfect record. The roots of the 1 meter or 3 foot long rock were first deposited about 107,000 years ago. For the next 16,000 years, it continued to accumulate layers of dissolved material that included an iron compound called magnetite, helpfully recording information about Earth's magnetic field. The stalagmite was cut into more than 190 samples and analyzed using a high-resolution cryogenic magnetometer, providing a century-scale resolution of Earth's magnetic field direction and strength 100,000 years ago. Among several smaller drifts in polarity, they spotted a flicker of a reversal some 98,000 years ago, and that stayed in place for a century or two before slipping back again. On a geological timescale, this excursion is shockingly brief and could suggest any significant changes to our protective shell will not come with much warning. The record provides important insights into ancient magnetic field behavior, which has turned out to vary much more rapidly than previously thought, Roberts explains. The data suggests that as the planet's field weakens, fluctuations in its strength increase, pointing to instabilities in geological activity closer to Earth's outer core. Technically, we're overdue for a reversal, though nature does not keep a diary, so we're not sure how worried we should be. Still, our field is getting weaker decade by decade, and we know that the North Pole is going from Canada to Siberia at a whopping 30 miles a year. That is really strange, and they don't know why that's happening. So our field is getting weaker decade by decade. Some speculate it's pointing to another excursion, even if not a full-blown reversal. Research like this suggests big changes in our magnetic field could be imminent, so it's good that scientists are, of course, paying attention to this. Again, they don't know why it's happening. The research was published on PNAS. This was by Mike McRae of Science Alert, and it's on Bended Reality. Please leave your comments, and thank you for your support. And this is a very good diagram showing us how the magnetic North Pole is moving. You can see it from 1900s, moving slightly, and then a very big leap from 1980 to 2000, and from 2000 to 2010, and 2010 to 2020, and it's projected 2025. It's really going fast. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.